Good morning, students. Pushti sir again to discuss an extremely important question on Newton's law for you. This will be very interesting one and quite conceptual one also. Let us see what is the question. Just see here. We have a frictionless pulley hanging from a rigid roof, a massless inextensible string passing over a pulley that passes over that pulley and supporting two identical blocks at both ends. So obviously this will be in equilibrium. Right now, let us say it is in static equilibrium. Okay, because it has no reason to go either this way or that way. So it is in static equilibrium. That's what I written in the question. A massless inextensible string passes over a light frictionless pulley which is fixed to the rigid roof that are shown in the diagram. Two identical blocks of mass m each are attached to both ends of the string so that the system is in static equilibrium. There is no motion for either of the blocks. The right block is hanging at a distance h. So see h below the roof, h below the pulley. So length of the string on the right side, it is h. I take this O at the center, O as the origin of this point as taken as O, and from O this is the radius vector or position vector r. That's what also I've said. So okay, so the right block is hanging at a distance capital H below the pulley. The right block is given a sudden instantaneous velocity v naught is which is equal to root over gh, g capital H, root over g capital H, and it's given to the right suddenly. Okay, so question में find करो, क्या find करे? Question 1, the acceleration of the left block immediately after the right block is given that velocity. Instantaneously when this velocity is given to the right block, what is the acceleration of the left block? Okay, this right string will undergo angular deviation, whereas the left string will not have any angular deviation, it will remain vertical only. Okay, so that's what he is asking, the acceleration of the left block immediately after the right block is given the velocity. And second question is the tension in the string immediately after the right block is given the velocity. So find the acceleration of the left block and the tension in the string immediately after the velocity is imparted to the right block. Yes, sir? समझ में आ गया क्वेश्चन? इसका सॉल्यूशन निकालते हैं. So as the right block is given a velocity to the right, its acceleration will have two components along the radial direction. This is the radial direction. It has two components. आप बोलेंगे भाई radial direction में two component क्या है? Because it is having an angular displacement, so it will have some angular velocity at this instant. So it will have a centripetal acceleration towards this O. And also, since the string is about to, this is free to move, so the string length can increase or change. So that may lead to a velocity VR. VR means velocity along the r direction that may change from 0 to non-zero value. So both accelerations, one in VR derivative, and is a centripetal acceleration, both are possible for A. Whereas for this the left block, only one acceleration, which is the VR change of VR will happen because there is no centripetal acceleration here, because this string does not undergo any angular displacement. So that should be clear for you. So as the right block is given a velocity to the right, its acceleration will have two components along the radial direction. मैं diagram में दिखाइए right block का. Right block acceleration is in radial direction shown by the red arrow mark. One is dvr by dt, that's what I told, that is d square r by dt square downward, and a step cp. A cp means centripetal acceleration, v naught square by r upward. So you may say, why VR initially 0 hai. So VR may be 0 initially, but dVR by dt need not be 0 at the string is free to move down. Yes or no? So rate of change of VR may not be 0. Okay, R is some H value initially, VR is 0, but once this motion starts, once I give horizontal instantaneous velocity V naught to the right block, so both this VR also can change from 0 to non-zero. So that gives us a dVR by dt or d square R by dt square acceleration component downward. And since this is having a tangential velocity or perpendicular velocity to the string, so it will give us a centripetal acceleration towards center upward. Okay, let me write it as O. Okay, I've shown you what is the O in this. Only this part I'm showing, other parts I'm not showing. This is O. Okay. So now this is the right block. There's a tension T dash, mg downward, net AR downward I'm showing. Net radial acceleration downward direction will be how much? AR net d square R by dt square downward and V naught square by R upward. So net is d square R by dt square minus V naught square by R. A net will be this, thus net of these two. Net of these two. This minus this, that is d square by dt square minus V naught square by R. This is the AR net. So AR net in downward direction, because I am subtracting V naught square by R from d square by dt square, net will be downward. So that net downward force will be mg minus T dash. T dash is the tension immediately after the velocity is given to the right block. Okay. Okay. So this T dash is the tension. T dash is the tension. T dash is the tension in the string immediately after the right block is given velocity. Understood this? This is T dash. So mg downward. Okay, mg downward, T dash upward. So net for downward is mg minus T dash is m into AR net downward. AR net downward is square R by dt square minus V naught square by R. So I wrote it here. Okay. So initially R is H. See the diagram I've shown you. R is H initially. Okay. So you can write mg minus T dash is m into d square R by dt square minus V naught square by H. Clear? Okay. That's what I wrote here. D square by dt square is the component of acceleration along R contributing to the rate of change of velocity along R. That is the rate of change of VR is the d square R by dt square. That is dVR by dt. VR is dr by dt. So d square R by dt square will be dVR by dt. That is the component of acceleration which leads to the change of VR and which also leads to change of R also. Okay. Am I clear? So the left block has a motion only along vertical. Now come to the left block. Left block has motion only along the vertical, this left block. Okay, that's what you are obviously seeing this. So the left block has motion only along the vertical. Since the left string does not rotate, it remains vertical. The left block has no centripetal acceleration. Obviously, there is no angular velocity, means it has no centripetal acceleration component. Okay. it has only radial acceleration dvr by dt, which is d square r by dt square in upward direction. Why upward direction? ये downward है right hand side dvr by dt, so left side का क्यों upward होगा? Because string is inextensible. D square r by dt square for both the blocks have the same magnitude but in opposite direction. If right is in downward direction, d square r by dt square, here I have shown for right block d square r by dt square downward direction. So for the left block, d square r by dt square will be upward direction. Both will be same in magnitude because this is from the constraint. The length remains constant. If it comes down by 1 millimeter downward in left, in the right, then it should go up 1 millimeter upward in the left. So their velocity also will be same in magnitude, and so also their derivative of the velocity d square r by dt square will be same in magnitude but in opposite direction. Right one is downward direction, upward is left one is upward direction. Now for the left block, this is the left block I am showing you. Applying the Newton's second law again, T dash, because same tension, because the pulley is having no friction and the string is massless, so same tension, T dash minus mg upward net upward force is equal to m d square r by dt square. There is upward acceleration. Only one component of acceleration. There is no centripetal term. So now equation 3 and equation 4. This is equation 3, mg minus T dash. Equation 4 is T dash minus mg, and that is m d square r by डी स्क्वायर. दोनों को ऐड कर दो, लेफ्ट हैंड साइड 0 हो जाएगा, राइट हैंड साइड हो जाएगा 2 डी स्क्वायर r by dt स्क्वायर माइनस v स्क्वायर by h. अभी दिखा देता हूँ, ये इसके साथ डी स्क्वायर r by dt स्क्वायर को ऐड कर देना पड़ेगा. तो 2 डी स्क्वायर r by dt स्क्वायर माइनस v स्क्वायर by h. अब बोलेंगे m किधर गया, m को कैंसिल कर देंगे, लेफ्ट हैंड साइड 0 है तो m कैंसिल हो गया, m को भी निकाल दिया फ्रॉम द राइट, कॉमन, दैट इज अ कॉमन टर्म. So d square by dt square is half of v square by v naught square by h. ठीक है. So but v naught square कितना है, आपको मैं शुरू से क्वेश्चन में बता दिया. is given a horizontal velocity v naught equal to root over gh. So root over gh का square is gh by h is cancel, so g by 2. तो आ गया आपका d square r by dt square. d square r by dt square is g by 2. ये g by 2 है, and लेफ्ट का ये अपवर्ड भी g by 2 है. ठीक है. It is given that v naught is root over gh in the question. So acceleration of the left block immediately after right block is given मैं कुछ उल्टा सीधा लिख दिया. हाँ, the acceleration of the left block immediately after the right block is given, the velocity is equal to g by 2. ठीक लिखा मैंने. Okay. So the answer to question number 1, acceleration of the left block immediately after the right block is given, and given an instantaneous velocity root over gh to the right. So in that instant, at that instant, the acceleration of the upper block is, the left block is upward direction g by 2. So then t dash कैसे मिलेगा, आप इक्वेशन 4 में डाल दो इसको, ये मालूम हो गया g by 2. So mg को इधर ले आओ, तो 3mg by 2 हो जाएगा, t dash खत्म है. So this is the t dash. This is the question number 2 का आंसर. So in the initial condition, t is equal to mg for both the case, both the blocks. Initially, the tension t was mg. Now it is t dash has simply jumped to 3 by 2 mg. Okay. Tension suddenly changes to 3 by 2 mg immediately after the right block given the velocity v naught root over gh to the right. ये आप ऑब्जर्व कर सकते हो. तो बहुत इंपॉर्टेंट क्वेश्चन है, इजी क्वेश्चन है, बट काफी माने महत्वपूर्ण क्वेश्चन है ये. आप अगर ये कॉन्सेप्ट समझ में आ गया तो आप बहुत कुछ कर सकते हो ये जो कर्व मोशन में. ओके. तो ऐसा ऐसे छोटे छोटे क्वेश्चन मैं आपको दूंगा, सो दैट यू कैन अंडरस्टैंड द concept of curved motion. Okay. Slowly I'll build up that concept for you. So all of you clear? I hope you have understood the concept. And if you have not understood the concept, go through this and contact me. I'll clarify again to you. Go through my a note also. This is because this is a unique type of lecture, because it's not just giving just problem and solution. I'm giving each and every detail of my argument also in the writing. Okay, I think you can read the handwritings, no problem. All of you clear? So go and prepare for your upcoming examinations. All the best to all of you. Have a good day. We'll meet very soon with the new topic, with a new key concept. Thank you all.